Week 10 Notes, Finding the GCF, Part 2. In this video, we're going to learn how to find the GCF of terms that have variables in them. So our first example is going to have only variables so that we can figure out what to do. X to the third, y squared, z. And x squared y to the fifth power z. It means we're multiplying together these variables, but this is a term and this is a term. How on earth do we find the GCF of these two things? Follow this method very carefully. The GCF is whatever we have in common with our variables. So let me ask that a different way. Which variables do we have in common? Which letters do we have in common? We have an X in common. Underline that, underline that. Right down here, X with a little box up here, meaning x to the power of something. What that something is, I will explain in just a moment. Next one, do we have any other variables in common? We have a y and a y, so then y is in common. So write y to the power of something. Finally, we have a z in common. So we're going to write z to the power of something. So x, y, and z are all in common. What do we write in these boxes though? Well, here is the rule. We look at the exponents of the common variable. If they are the same, then that is what we write in the box. If they are not the same, then we're going to pick the one that is lower. So looking at x to the third and x squared. Are they the same? No. Then which one is lower? It's x squared. So it's the 2 that we're going to write in the box. Let's look at y. Y squared and y to the fifth. Are the powers the same? No. Okay, that's fine. But which one is lower? The 2, clearly. So we're going to write the 2 in the box. And with z, z is just z to the 1. There's a 1 there. And are they the same? Of course. So that is what we write. And this, folks, is our GCF. We don't need to write the 1 there, so really it would just be x squared y squared z. That's how we find the GCF of variables. Now, I want you to try this next one. It's w to the fourth, x, y to the third, z, and x to the fifth, y. Interesting how I write my y's differently, but whatever. Try and find the GCF of these two terms the way I did. So assuming you've tried, the GCF is, well, find the common variables. Is w in common to both? No, clearly not. How about x? Yes. Underline it. This is x to the 1, by the way. So we'll put x to the something because x is in common. How about y? Yes. And y to the something. This is our GCF. How about z? Nope. It's not in this term. So it's not common. What do we write in the x box? The x box. I did not mean to say that. Okay, which variable, or not variable, but which power is lower? Or are they the same? If they're the same, we write whatever it is. But no, it's not the same. The 1 is lower, so we write the 1. Whatever one's lower, or if they are the same. How about y? Are they the same? There's a 1 here. No, they're not, but the 1 is lower, so we will write the 1. So really, you guys, the GCF is xy. You don't need to write the 1s there. But you do need to know they are there. Okay, one more here. 30x squared y to the 5th z, and 36x to the 5th y squared zw. All right, so how do we find the GCF of this whole monstrosity right here? The steps are actually not that hard. You know how to do it already. Let me just tell you that, or tell you how to do it. Okay, so you first find the GCF of the numbers, 30 and 36. We did that in the last video, actually with those very same numbers, but let's use our method again. 30 and 36. You might be able to know right off the bat that the answer is 6, but if you didn't know that the answer is 6 right off the bat, you could see that they are both divisible by 2. 30 divided by 2 is 15. 36 divided by 2 is 18. And then these are both divisible by 3. And then you're left with 5 and 6. These are no longer divisible by anything in common but 1, so we're going to multiply 2 times 3 is 6, okay? You can divide 30 and 36 by 2 and then by 3. Same as dividing by 6. So 6 is the greatest common factor of the numbers. And then we look at the variables. So x and x are common. I'm going to underline that. And then I'm going to put x with a box. I'm just doing this very, very step by step. I mean, if you want to write this answer already and you're getting bored, you can go right ahead. But if you're still lost, this is for you. Y to the 5th and y to the 2nd. Y is also a common variable. So I write y with a box, y to the power of something. Finally, we have z in common. So I write z to the power of something. Now, what do I write in the boxes? If they are the same, that's what I write. They, meaning the exponents. X to the 2nd, x to the 5th, not the same. But then I just take the lower one. X to the 2nd, the lower one, guys. The lower one. All right, x to the 2nd. Let's try that again. All right. Then y to the 5th, y to the 2nd. Clearly they're not the same, but 2 is the lower one. Kind of a perfectionist, sorry. And then we have z to the 1st, z to the 1st. They're the same, so then that means 1 is what it is. X to the 2nd, y to the 2nd, z. This is the variable part right here. This over here was the number, and what we're going to do is we're just going to multiply those together. So our answer is, drum roll please, GCF equals 6x squared y squared z. That is how you find the GCF of that thing there. And one more. This one I want you to try on your own here. 23a squared b squared c and 46 a cubed c. Find the GCF of these two terms, just like I did over here. So you may know right away that the GCF of the numbers is 23, because 46 can be divided by 23. And you can obviously divide 23 by itself. So the GCF of the numbers Well, I'm going to just keep 23 over here. That's the GCF of the numbers. And now we have to go to the variables. A squared, A cubed, A is in common. So I'm going to write A to the something because it's in common. B, is that in common? Nope. C, is that in common? Yes. That's C to the 1, C to the 1. C is in common. And we know since that's the same, I can just put a 1 in there. And then the lower one of the A's is 2. Right there you can see. And then, folks, all we have to do is multiply these guys together. And the GCF is there 4. Drum roll, please. And yeah, I do want you to drum roll at home. 23A squared C. And that is the GCF.